Welcome to factoring quadratic trinomials with leading coefficient not being equal to 1. Here is your first example. This here is a quadratic trinomial with leading coefficient of 3 that does not have any GCF to take outside as is, so we have to set it up for factoring by grouping. To factor by grouping, you are required to have 4 terms. And right now you are only presented with 3 terms. To create 4 terms, we will need to remove the middle term negative 1x and replace it with 2 numbers, each will have an x. Here is the procedure to find what numbers we will be replacing negative 1x with. You will first multiply the leading coefficient by the constant term. 3 times negative 4 is negative 12. You will then find all of the possible pairs of numbers that multiply to negative 12. And then you will go through addition of each pair of these numbers to see which pair also adds to the number in the middle, which is negative 1. So the pair of numbers that we will use to replace negative 1x with is 3 and negative 4. So I'm going to write this problem over, and in place of negative 1x, I will be writing positive 3x and negative 4x from this pair. Now I will be factoring with grouping. To do that, I will group 2 terms in one set of parentheses and find the greatest common factor for each group. For the first group, it is as 3x. And if 3x is dividing the first and the second term, you will be left with x plus 1. For the second group, the GCF will be 4, but since the first and the second terms are both negative, I will be taking out a negative 4. And if you divide negative 4x by negative 4, it's x. And if you divide negative 4 by negative 4, it's positive 1. The final step in factoring is to locate your matching binomials. Here it's x plus 1. We write it once in the front. And then in the second set of parentheses, you collect all of the non-matching terms. This is it. Let's look at another example. Here's another example with the leading coefficient of 49. As of right now, it has no greatest common factor to take out from all 3 terms, so we will have to set it up for factoring by grouping. For that, I will be removing negative 28x and replacing it with 2 numbers that I will find through the same procedure I used in the first example. So first I'll multiply 49 by 4. It is 196. And then I will break 196 down to multiples to see which pair will add to this negative 28. So here I listed 4 pairs, and there are more, but I will stop at negative 14 and negative 14 because I know that not only do these 2 numbers multiply to make a 196, they also add to the middle number of negative 28. So I'm ready to write the problem with 4 terms so that it's set up for grouping factoring. From the first group, the GCF is a 7x, and if you divide each of these terms by a 7x, you will be left with 7x minus 2. From the second group, I will pull out a 2 because 14 and 4 are both divisible by 2, but since the front number in that group is negative, I will be taking out a negative 2. So now the matching binomials are 7x minus 2. You write it once in the front, and then all of the remaining things are also 7x minus 2. Now, as you can see, the 2 factors that we got are identical, and you can leave your answer like this, Or you can write it in a shorter way of 7x minus 2 squared. Either way is correct. This factoring technique can of course be applied to solving quadratic equations with factoring, just like any other factoring technique. So here's an example of an equation. It has an equal sign, and just like before, we have to make sure that the right side of the equation, where I currently have my negative 31x, has a 0. So negative 31x will need to be taken to the left side by becoming positive 31x. When you write in your 31x on the left side, make sure that you put it in between two existing terms so that your x's come in order and the term with the x is in the middle. Now we'll go through the procedure of finding two numbers that will be replacing 31x in the middle. I will multiply 6 by 5, that's a 30. And I need two numbers that multiply to 30 and also add to 31. And that pair is 30 and 1, because if you multiply them, you get a 30, and if you add them, you get a 31. So I'll write my question over, and 31x will be replaced with 30x plus 1x. Now I will group. From the first group, the GCF is 6x. From the second group, the GCF is positive 1. The matching binomials are x plus 5 and x plus 5. You write it once in the front, and then all of the remaining things are 6x plus 1 go into the second set of parentheses. If this was a factoring problem, you would stop right here, but this is a solve the equation problem, so we have to have that extra step of setting each factor separately equal to 0. To solve the first little equation, you have to take the positive 5, make it negative on the right side. So the first answer for this equation is negative 5. For the second equation, first step is remove the 1 by subtracting it. And then remove the 6 through division. So the second answer is x equals negative 1 over 6. Here's the last example of this recording. This is also an equation. It does ask you to solve, and it has that equal sign. The good news is it's already equal to 0, so we don't have to move any terms from right to left. But I want you to notice something before you start going through the procedure of breaking down this 11x in the middle. All terms currently have at least one x. Here you have x cubed, which is 3x's multiplied by each other. Here you have two of them, and here you have one. If that is the case, your current trinomial has a GCF that you need to take outside before you start doing any other factoring. So the GCF here is x, and I will go ahead and take that x outside, which will make the first term here, instead of being 12x cubed, it's going to become 12x squared. The second term, instead of being 11x squared, will become 11x. And then the 2x will become just a 2. So you divided every term in the original problem by x. And we keep writing equals to 0. So now I will ignore this x here for the time being, and I will factor the inside trinomial as we have been doing. So I need my 11x in the middle broken down into two numbers. I will go ahead and multiply 12 by 2, which is 24. And I need two numbers that not only multiply to 24, but also add to positive 11. So those numbers are 8 and 3. I will now be rewriting the trinomial in parentheses here. But instead of 11x, I will write 8x and 3x. For now, I will not be carrying this x with me, just so that I'm not confused with all of the parentheses. But we keep in mind that we have that x in the front for our solving procedure at the end. So my trinomial in the parentheses is now going to be 12x to the second plus 8x plus 3x plus 2. We will factor with grouping. So from the first group, you're going to take out 4x, that's your GCF, which leaves you with 3x plus 2. From the second group, take out 1, which leaves you with 3x plus 2. The matching binomials are 3x plus 2, write it once in the front. The non-matching things are 4x plus 1. And now I will go ahead and take this x that I took outside in the beginning and put it in the front. And we'll write equals to 0 because that's what we had in the beginning. What you have here is a factored polynomial with 1, 2, 3 factors. Each of these factors will have to be set equal to 0. So your first factor is x, and you're going to set that equal to 0, and that is your first answer. Your second factor is 3x plus 2. You set that equal to 0. This one requires solving, so we will take 2 to the right side by making it negative. And then you divide both sides by 3. X is negative 2/3. And then you set your third factor equal to 0. To solve this, you will subtract the 1 and divide both sides by 4. So this equation actually has 3 answers, a 0, negative 2/3, and negative 1/4. An easy way to determine how many answers your equation will have is to look at the degree of the original polynomial. If the degree was 2, we would have 2 answers. But here the degree was 3, so the expectation is that you will have 3 answers. And if you don't get 3 answers, you're likely doing something wrong, so you might want to go back and check. Maybe you forgot about this x that you took outside, maybe you forgot to take it outside. So make sure that you compare the degree of the polynomial with the number of your answers to the equation at the end.